Greetings, math fans. All right, so this is Chapter 9, Day 2. Chapter 9, Day 2. And basically what we're going to talk about today are X and Y intercepts. So X and Y intercepts. Okay? So let's just take a look at a graph. So, of course, you know this is the x-axis and this is the y-axis. Okay, that's actually significant to, very important to know. Okay, so if I gave you a graph like this, and I just kind of to label things here a little bit. I mean, we have some points. Obviously, this is where it's crossing the axis, and these are x and y intercepts. So just think. Let me put a couple of numbers to this here. So this is 1, 2, 3, -1, -2, -3. We'll say that's -4. This is 1, 2, 3, 4. This is 5, 6, 7, 8, 9, 10, 11. And we'll just go with 12. Okay. So an x-intercept, if I actually would label those points, or even the y-intercept, let's just label all the points. We'll do it in a different color here. So this is going to be degree. This is -4, 0 for this one right here. And this one on top here is 0, 3. And the one over on the right here is 5, 0. And the one even farther to the right is 12, 0. Okay, so notice x-intercept is where, so let's just write this down here. An x-intercept is where it crosses the x-axis. So it kind of makes sense, doesn't it? X-intercept crosses the x-axis. So that my or the x-intercepts would be this guy, and this guy. And notice they are coordinates. This is really important. Okay, don't give me a number. Don't tell me, oh, what is the x-intercept, and say 12. I'll say 12 chickens. Okay, it's got to be 12, 0. It's a coordinate. It's an intercept. It's a location. Okay, so 12 is not a location. 12, 0 is a location. Okay, so an x-intercept is, of course, where it crosses the x-axis. And then, of course, if I say the y-intercept, that's where it crosses the y-axis. Okay, so you would tell me that this one, of course, is a y-intercept. Okay, 0, 3. Now I want you kind of to notice something it's pretty significant here. When I'm looking for the x-intercept, what is always true? Well, -4, 0, 5, 0, 12, 0. So when he crosses the x-axis, or the x-axis is the x-intercept, what is the value of y always? Okay, so y is always equal to 0. Sometimes people get confused. They say, oh, x-intercept, and they go, oh, it's when x is 0. Well, no, look at it. X can be -4 and 5 and 12. X doesn't have to be 0. Okay, it's y that has to be 0. Why? Because it's just look at the coordinate of each of these. Okay, so y is equal to 0. Super important. And then again, or then we look at the y-intercept. Okay, it's 0, 3. So what's true about that guy? Well, don't you guys agree x has to be equal to 0 because I'm on the y-axis. So the x value is 0 no matter where it crosses. Okay, super important. This is like ultra super important when you're talking about x and y intercepts. Okay, with x-intercept, the y equals 0, and y-intercept, the x is 0. Because, again, you're trying to find values of x where it's crossing the x-axis, and you're trying to find values of y where it's crossing the y-axis. Okay, all right. So that's pretty important. Also, I want to point out here, math fans, there's only one y-intercept for any problem. Only one. In fact, there's always one intercept for a function. Always, always, always one intercept. Okay, as far as the x-intercept, here, let me delete all this stuff here, just kind of show you. I would say how many x-intercepts are there? Well, here there are 3, but let me do a couple examples. Here's a graph. Here's an example of 2 x-intercepts. Right here and right here. Again, this guy right here, that's my y-intercept, right? Okay, so that's an example of 2 x-intercepts. How about 1 x-intercept? How about if I just touch the line? So the graph looks like this. Here we go. One x-intercept. It's just touching the line. So that's one x-intercept. Can I have something where there's no x-intercept? Of course. Here's no x-intercept. Never even crosses the x-axis. Just goes down. Okay? And then, of course, I can have like 1,000 of them. If I draw a graph, here we go. 1,000. Boo. Right. So every time it crosses, that's an x-intercept. X-intercept, x-intercept, x-intercept. So that one, you could have as many as you want. So you don't have to have any. You can have one, you can have two, you can have 5.2 billion. Okay? You always have one y-intercept. And if I take a look at it, again, here's the y-intercept. This would have crossed somewhere up there. This would have crossed somewhere down there. Here's a y-intercept. So I'm always going to have a y-intercept. Okay? But remember, to find the x-intercept, okay, you set y to 0. And to find the y-intercept, you set x to 0. Super, super important. Okay, so let's do an example here. First of all, this is a little notation. F of x equals x squared minus 4x minus 12. The first thing I want to talk about is this f of x can also be written as g of x, h of x, m of x, p of x. So in other words, you can use any letter you want. I'm not trying to use specific ones. You can use any letter you want. What these all represent, math fans, for what we're using now, they all represent the letter y. So y equals x squared minus 4x minus 12. Okay, so don't panic and go, what the heck is it, g of x or h of x or p of x or s of x? You guys need to understand that it's just like saying y equals. It's just a function. We call it a function because you can. This doesn't have to be an xy graph. This could be temperature, could be pressure, could be so many different things. That's why they just say f of x is just a function. Okay. So let me give you. So here I gave you this problem here. Let me actually erase this bold thing I just wrote. Okay. So I gave you that function f of x equals x squared minus 4x minus 12, and I'm going to ask you for the x and y intercept. All right. So remember, in order to find the y-intercept, which I'm going to do that one first. Y-intercept, you're going to set x equals 0. This is easy. Super easy. Okay, because if I set, just look at it. Here again. Here, let me highlight what we got here. This is my function. If I set x equal to 0, do you guys agree that x squared cancels out? So it's like 0 squared minus 4 times 0. Everything cancels out except for the negative 12. So that's what the answer is, negative 12. And so you give me a coordinate of 0, negative 12. That's the y-intercept. Okay? That's really easy. The x-intercept is a little more challenging. So let's do that. It's x squared. So you're going to set, I should write this on here, set y equals 0. So you get y, or x squared minus 4x minus 12 equals 0. Okay, so you set the y equal to 0. And guys, this is like factoring. This is what we've been doing for like the past 2 months. Okay, you got to factor that. So if I factor that, I get x minus 6, x plus 2. Again, I don't care how you factor it. And you get x equals 6 and x equals negative 2. So my answer for this problem for y-intercept was this guy right here. So let me write it in a different color. This is my y-intercept. 0, negative 12. And my x-intercept is 6, 0 and negative 2, 0. Okay, and that's my answer. Those are my two answers. Negative 6, 0, or 6, 0 and negative 2, 0. And those are my x-intercepts. Okay, it's pretty easy, really. All right, so let me give you another one here. Okay, let's do g of x. Nice little letter, right? It doesn't matter. G of x equals 2x squared minus 5x minus 12. Okay, so again, I'm looking for the x and y intercepts. I'm going to do the y-intercept first because it's super easy. Remember, you set x equal to 0. So here it is, g of, I'm going to put 0, g of 0, because that's kind of what it is. the x is 0. So t of x, g of 0. And we're going to plug in a 2, or we're going to plug in a 0 into that equation. So 2 times 0 squared minus 5 times 0 minus 12. So this cancels out, cancels out. So that's why the beauty of it is this is just negative 12. So my y-intercept is 0, negative 12. Okay? Pretty easy, right? All right, let's do x-intercept. We're going to set y equals 0. Okay, so 2x squared minus 5x minus 12. Let's set that equals 0. And then you got to factor it. Okay, again, I'm going to use a factor box. 2x squared, negative 12. You're going to use something different, probably. Maybe, I don't know. So you get 2x and x. And you want to try different combinations here. So we can try, see, it's going to be a 4 and a 3, I believe. Because that's going to give me 8x and then 3x. It's negative 5x, so this has to be negative here. So negative 8x. Okay. So, guys, please, this is important. We don't use that much, but this is what it looks like. It's 2x plus 3 times x minus 4. All right, and let's solve. So 2x plus 3 equals 0. X minus 4 equals 0. Subtract 3. 2x equals negative 3. Divide by 2. X is negative 3 halves. And this one's add 4 to both sides. So x equals 4. So there we go. Your x-intercept is kind of crazy. It's negative 3 halves, comma 0, and 4, comma 0. That's it. It looks a little complicated, but it's not bad. So that's x-intercept, and of course this top one here was my y-intercept. Okay? Not bad. Let's do one more. Actually, I have 2 more to do with you guys. Okay, so h of x is equal to 2x cubed minus 4x squared minus 15. Minus 30x. There we go. Okay, cool. All right, so again, the y-intercept is super easy. Set x equals 0. Everyone should get this. So easy. So what happens when you put a 0 in for this one? Do you guys agree everything cancels out and you just get h of 0 equals 0? So my y-intercept is 0, comma 0. That's super easy. Let's do x-intercept. Not as easy. We set y equals 0. So it's 2x cubed minus 4x squared minus 30x equals 0. Okay, what's the first thing you're going to do? Greatest common factor, man. And then you should see that's a 2x. So you got 2x, and then I have x squared minus 2x minus 15 equals 0. Okay, and then if you do a factor box with this, you get x minus 5x plus 3. So 2x equals 0, x minus 5 equals 0, x plus 3 equals 0. Well, the first one's going to give you, divide by 2, x is 0. This one's going to give you x equals 5. And this one's going to give you x equals negative 3. There we go, mate, guys. 3 answers. Please do not leave them as x equals. Okay, you're going to tell me, again, this is my y-intercept on top here. So it's my y-intercept, and then the x-intercept, you're going to say, so this is x-intercept. 0, 0, 5, 0, and negative 3, 0. And that, math fans, is the answer, that end of that problem. Okay, so x-intercept, and this is an x here. Look a little cleaner here. That's x. Okay, got your x-intercept and y-intercept. Again, set y equals 0, set y equals 0 to find the x-intercept, and set x equals 0 to find the y-intercept. Okay, kind of opposite of what you almost would think. All right, but if you're not sure, draw a quick sketch. Okay, and look where, pick a point on the x-axis and go, oh wait, that x-axis is 5, 0. Oh wait, x is 5, it's not 0. Okay, the only way it's going to be 0 is 0, 0, which is the origin, which actually for this problem, it actually came out to be one of the answers. 0, 0 happened to be x and y in the same problem. Their same intercept. Okay, last problem is p of x, just use a different letter there, negative x squared plus 2x plus 8. Okay, so again, the y-intercept is super easy. You basically set x equal to 0. What you do, the x squared cancels and the 2x cancels, and you just have x or y equals 8. So my coordinate is 0, 8. Super easy. Okay, x-intercept, not as easy. We're going to set y equal to 0. Of course, that's like saying p of x equals 0, so we get negative x squared plus 2x plus 8 equals 0. So I'm going to get rid of that negative. All right, if I get rid of the negative, that makes it a lot easier to factor. So you get x squared minus 2x minus 8 equals 0. So again, I don't care how you factor it, factor box, whatever, but you get x minus 4x plus 2. So x equals 4 and x equals negative 2. Okay, so those coordinates are going to be 4, 0 and negative 2, 0. Okay, so that's it, my friends. That's pretty much how you do this unit. Is pretty straightforward. It's just x and y intercepts, and like recognizing them on the graph, and also in an equation, and knowing what to do. Set what equal to 0 and solve. Okay, so that's it, my fans. Hopefully you guys are good to go, and you have an outstanding day. Adios. Goodbye.